Howdy, howdy, this is Mr. Potter. We're continuing our discussion about inheritance, and so I've actually got three classes here, and they all extend each other. These are not abstract classes, so I'll be able to create all three of these classes, and it's actually kind of important that I be able to. So what I've got here is I've got a class called 1, and my class called 1 has two variables, first and second. And although you shouldn't make your variables public for security reasons, for that encapsulation that we've talked about throughout this course, I'm going to have my variables public just so I can illustrate a point here. So I've got public int first, public int second, and I've got a default constructor which sets first to 1 and second to 2. And then it calls on this method called printit. And what printit does is it prints out an object here. So I've got first is first and second is second. And then I have a overloaded constructor which assigns first and second to values that I give it. I've done the same thing with 2, except 2 extends 1. But 2 has a variable called second and 2 has a variable called third. And notice that because 2 extends 1 and 1 had a variable called second, there's a possibility for some collisions happening here. There's a possibility for some uncertainty to happen here. And so what I want to do is I want to kind of discover what's going to happen with these variables here. So my class 2, I've got a variable called second, a variable called third, and because I'm extending 1, I also do have reach back to that variable called first in the class 1. So because we're extending that, we're calling on that. So my default constructor assigns first the value of 3, it assigns second the value of 4, and it assigns third the value 5. And then I also call on the printit method, which I've got down here. My printit method prints out first, prints out second, prints out third, tab space. And I have an overloaded constructor as well. 2 extends 1, 3 actually extends 2. And in this class 3, I'm only declaring two variables, first and third, but I should be able to reach back to get variable 2. And so I've got first is being assigned 10, second is being assigned 11, and third is being assigned 12 in my default constructor, again calling on the printit method. And I've got an overloaded constructor and a printed method. So with these three classes, 1, 2, and 3, each of which kind of extends the one that came before it, I want to talk about what happens when I create an object. So if I create an object of type 1, it's going to be pretty straightforward. So I'm going to just system out println creating a 1. So I'm going to say 1a gets new 1 using the 1 constructor. And keep in mind that my default constructor for the 1 class will assign 1 to first variable, it will assign 2 to second variable, and then it'll call on this printed method. So I should see first and second listed down here. So let's go ahead and run this. And of course, notice what it did is that it assigned those variables. First is 1, second is 2, and it printed the method that said, hey, here's first and here's second. What's more interesting is what happens when I decide to system out println. And I'm going to put in a new line and then creating a 2. And I'm going to say 2b gets new 2. Keep in mind that a 2 extends 1. So in other words, this variable, I'm calling on 2's constructor. And so first is 3, second is 4, and third is 5, and then we're going to print it. So when I'm done with this constructor, I should have first containing a 3, I should have second containing a 4, and third is containing a 5. And then I'm going to go ahead and create a new 2 object. This stuff here for 1 should stay the same, but notice two things happened here. The first thing it said is creating a 2, first is 1, second is 0, third is 0. And then it says first is 3, second is 4, third is 5. And the problem is that when I create a 2 object, the very first thing it does, and we don't see it, is that it calls on the super constructor. It calls on that default super constructor, which is a problem. Because what does my super constructor do? Well, the constructor for 1 declares a variable called first and declares a variable called second. And so first contains a 1, second contains a 2, and then here is my 2 class. It doesn't have a variable called first, so first is still 1. but it does have a variable called second, which kind of overlaps the second variable in class 1. And as a result, it doesn't contain anything new. So it only contains the 0. That's the default element when I'm talking about an int. And third hasn't been assigned yet. So when this one object calls on print it, one looks at itself and says, you know what? This is a 2. What does 2 do with print it? Well, it drops down here and it prints out first, second, and third. But it prints out the values for 1. So for class 1, first is 1. For class 2, well, we haven't assigned it a value yet, so that variable is empty. And for third, that value is 0, because we haven't assigned it anything yet. We still have to go through this process. So the thing is, our 2 class actually inherits a first variable from class 1. And really what we've got is public int first gets 1. And it also inherits a shadow variable from class 1 called second. But the thing is, I have 2 variables called second, and the 1 variable actually gets the assignment, but the 2 variable is what gets printed through printed, and that's why I don't see it here. And then, after it's called this super, then it calls on first is assigned to 3, second is assigned to 4, third is assigned to 5, and I get the expected predicted behavior. So this is a little peculiar, what's going on here. This is called first. If there's no default constructor in this constructor, it's going to call on the default constructor. Now, if I wanted to get around that, what I would do is I would do something like super passing it 3 and 4, because 1 had an overloaded constructor. It would call on primo, it would call on segundo, and put those values in. So let me try that. Let's see what happens if I put that call in first and just comment out these lines. So if I do that, compile that, and then I want to run my inheritance. Again, my 1 shouldn't change. I really could take that out. But notice now, because I've put in a default an overloaded super constructor, it's not calling on the default constructor. Remember that my overloaded constructor for class 1 didn't have a printed method. And so this does not do the printed. And so you may remember in our last video, I kind of made us use the overloaded constructor super when we wanted to create a dog element or when we wanted to create a cow element because of this very reason. The idea is that whenever I'm running a class that extends another class, either the super default constructor is going to get run first, and I have no control over that, or I can put a super where I want it. Now the thing is, a super is going to get called, and I have no control about the default constructor because the default constructor does what the default constructor does. But if there is an overloaded constructor, that gives me a little bit of control. So notice I got the super 3, 4, and then I've got the first gets 3 and the second gets 4, which I've kind of already taken care of with this. And then I call on print it. Because I use the overloaded super, then print it only gets called once, and we're good. So what I'm going to do is I'm going to comment out this and re-put those there, and just want to kind of re-go over the behavior that we get when I don't use a super constructor. So I'm going to recompile this, and I'm going to run this. And again, I really don't care about these lines of code. This worked basically traditionally, it's just getting in the way. But I want to talk about what happens when we create a to object. And this is what's peculiar about it. Creating a to object, this happens first here, this line right here. Notice I've got first is 1 and second is 0 and third is 0. Because class 2, the very first thing it's going to do is it's going to call this super default constructor. So what does this do? It assigns first a value of 1. This first gets a 1. And then it's going to assign second a value of 2. This second gets a 2. And then it calls on print it, but keep in mind this is a 2 object. It's going to do 2's print it because this overrides 1's print it. And so what it does is this is going to print 2's variables. But 2 didn't have a first. So if 2 didn't have a first, I have to jump back to 1's first, and that's the one that contains a 1. 2 does have a second, but keep in mind this second hasn't been assigned yet. Because when I called on the super default constructor, this second got a 2. Not 2's second, but 1's second. This is still empty, and so because it's empty, it contains a 0. Likewise, third doesn't have anything in it, so third is a 0 as well. That's where this blue line comes from. And then we assign and we assign and we assign and we call on print it, and this is our traditional expected behavior. What's going to be interesting is when I try and do 3. Because notice 3 extends 2, 2 extends 1, which means 3 is going to call on the super default constructor for 2, and 2 is going to call on the super default constructor for 1. So I've got this chain going back, and the printed method is actually going to be run thrice. It's going to be run 3 times. The first time with 1's data, the second time with 2's data, and the third time with 3's data. But it's always going to be running this method because my object is a member of the 3 class. So I want to create a 3, and I'm going to say 3C gets new 3. So I'm going to run this, and we're going to see the magic happen. Notice that because 3 extends 2 and 2 extends 1, that printed method that 3 has, this printed method here, is actually going to get run 3 times. Once by the 3 constructor at the very end with our expected values, 10, 11, and 12. And it's going to be run once by the 2 constructor. And it's going to be run once by the 1 constructor. Notice the 1 constructor assigns this value of 1, the 1 constructor assigns this value of 2, but then we jump over here. First doesn't have anything in it. There is no second in this class, but there is a second in this class, which we have not touched. We have not touched the second. So all of these values are 0, and that's why in this very first row, there's nothing here. The class 3's first object is here, the class 3's third object is here, but this is class 2's second object, none of which were assigned by class 1. The next thing, we've done the default constructor for 1. 1 has run completely through. We've called on print it. Now we're back at 2. We've done this super call. So now first gets 3, but remember that first is an element of this class. Second gets 4, but second doesn't exist in this class. So this is 2's second that gets the 4. And then third gets 5, but that's 3's. So this is going to get a 5. And we're calling print it, but we're calling print it from this realm. So the thing is, first doesn't have a value, still doesn't have a value, because 2's first is in 1. This first still hasn't gotten a value. This second got a 4, assigned right here. And this third is really 3's third, which hasn't gotten a value yet. And so when I call on printed, I get nothing and 4 and nothing. And then, now I get to 3. I've called the default constructor, and now I'm just assigning variables. First gets 10, second gets 11, third gets 12, print it, and it prints the 10, 11, and 12 as I expected. Now, if I want to take a look at this, keep in mind that C, I could system.out.println C dot first, or I could do C dot second, or I could do C dot third, and it's going to print out those values 10, 11, and 12. But I can actually access these older values if I tweak this 3 class. And what I can do is I can actually call on public void print it old. And what I'll do is I'll do system.out.println, and I'll do first colon, and I'll do super.first. And what this is going to do is it's going to go back to some first in the past and access it. And now we're going to do /t second, and we're going to call on super.second. So we're going to go into the second in the past. And then we're going to /t and find out what third is. And we're going to do super.third. And this is going to print the third in the past. So if I compile this, this should work. Because first exists in the past, it was here. Second exists in the past, it was here. And third exists in the past, it's here. And so if I do C dot print it old, I should see those older versions of the variables first, second, and third. So we're going to go ahead and compile 3 just to make sure I've got a good class here. I'm going to compile inheritance driver and run it. And notice what I see. 3 existed in the past. 3 existed in class 1. And 3 was assigned a value of 3 by the 2's constructor. Second existed in the past, but second also doesn't exist here. This class doesn't have a second. So when we assigned second gets 11, it was actually 2's second that got assigned. And as a result, second contains 11. And if I continue to delve back into the past, when we look at super for third, we're actually going back to the third that 2 had, and 2 assigned that third a 5. So I can actually access this data from the past, looking at the super call for first, second, and third. And I can do the same thing for this. What I can do is I can do public void print it old and do the same thing. Again, 1 doesn't have all of these variables, so I'm going to want to just take the variables that I have, which is first and second. But I can do the same thing, create a 2 object. So system.out.println, creating a 2, and 2b gets new 2, and do b.printit_old. And let me put a /n here just to break up the monotony. So the first thing I'm going to see, actually, did I compile 2? I did compile 2. So notice that we're going through the constructor of 2, which is the behavior we saw before for these 2 lines. And then we have this assignment here. We notice that first is 3 and second is 4. So let's investigate this. Going back to 2, keep in mind that 2 had a second, but 2 didn't have a first. So if I call on, oops, I forgot to put supers here. Let me remedy that. It would help if I did that. Should be super.first and super.second. .second. So let's compile that and rerun this like it never even happened. So notice what happened here when I called on super. My class 2 doesn't contain a first. There's no public int first here. And so I actually have to go back to class 1 because 1 was the most recent class that had a first, and we assigned it a value of 3. That's why a 3 shows up here. But when I call on super second, I had a second here, but this second got assigned in this default constructor. It got assigned a 2. And so calling on the super for a variable that didn't exist gives it the value we've given it anew. But calling it on a variable that did exist causes it to display its old value. So, I know this is confusing. It's very difficult to understand, and you kind of have to actually draw pictures and see what's happening here to see the 1 and the 2 and the 3 kind of in space, to see how the variables overlap each other, because it is difficult to understand. But this actually gives you a lot of power. This actually gives you a lot of finesse, because you can talk about my variable called second, but you can also talk about my predecessor's variable called second. And using the super reserved word, I can actually go back in time and access previous variables. I can go back in time and access previous methods. I could tell 3 to access 2's print it. I could tell 2 to access 1's print it. And so this gives me a lot of finesse, a lot of control, especially when classes share names. And so this is a very important aspect of inheritance that we kind of have to understand. And going through examples like this is really the only way to understand it. So once again, this is Mr. Potter. Thank you for watching. Have a great day.